Hi guys, this is Dr. T.S. and today I will be continuing our discussion on the properties of water and specifically be talking about how water is what we call a universal solvent. Now this is going to be a property that we talk about a lot, so it's one I really want you guys to take the time to understand. It's something that we are going to talk about many times throughout the semester. So first, let's talk about what it means to be a solvent. And in order to do that, we need to define a couple of terms and talk about something we call solutions. Now, solutions are a liquid that is homogeneous, meaning completely mixture of two substances. So you take two substances, you mix them together, and they completely form this homogeneous solution, okay? So I want to give you guys the example today of strawberry Kool-Aid. Strawberry Kool-Aid is my favorite type of Kool-Aid. Now, when you make strawberry Kool-Aid, you are going to need two things. The first thing you are going to need is water. This is our solvent. This will be what we put our Kool-Aid powder in to dissolve. So water is our solvent. It will be doing the dissolving. Then we need the actual Kool-Aid. We call this the solute. This is the thing that will be dissolved. So if I take this Kool-Aid powder and I put it into this water, okay? Let's pour a bunch of Kool-Aid powder in here and I mix it all together, I will get my solution. I will get my delicious strawberry Kool-Aid drink. So remember, solutions are a liquid that has been a mixture of two substances. Those two substances, one of them is a solute, which is going to be dissolved in the solvent. So in this example, water is the solvent and Kool-Aid is in a solute, and I get a solution of beautiful, wonderful strawberry Kool-Aid drink. So when I mention that water is a universal solvent, I mean that water is capable of drawing many different substances into solution. It is capable of dissolving lots and lots and lots of types of solutions, substances. And it has this is because it has a chemical structure that allows it to dissolve more substances than any other known liquid. Okay? So if we were to take other liquids, oil, other liquids we find on this planet, water is a universal solvent. It is incredibly good. It is able to dissolve more substances than any other liquid. And there are a couple of reasons for this. The first is that water is polar. Remember, what does the polar mean? It means that it is slightly charged, okay? Slightly charged. Because it is slightly charged, it can then dissolve other charged molecules. Because of this, water can break ionic bonds. Remember, ionic bonds form between two charged atoms, so like something like salt, sodium and chloride. So if I poured salt into water, the water would be able to break these apart and separate them, as you can kind of see in this image here. Additionally, water is capable of hydrogen bonding. So water can hydrogen bond with itself and create these distinct areas within the solution that it can kind of keep the sodium and chloride away from each other. So it's able to bring these structures into solution much more easily. However, that does not mean that water can dissolve everything. Substances that water can dissolve are called hydrophilic. So these are substances that water can draw into solution, okay? So things like salt, right? Sodium chloride. But there are plenty of substances out there that are hydrophobic. These are substances that water cannot draw into solution. So for example, here I have a bunch of oxygen that is double bonded with itself. Now when oxygen double bonds with itself, like in this image here, it is non-polar. Remember, non-polar means that these atoms are sharing their electrons equally. They have no charge. And that is going to be essential. So one of the biggest things that determines if a solution is, or substance is hydrophobic versus hydrophilic is whether or not it is polar or charged. Water, because itself is charged and polar, can dissolve other polar and charged things. One kind of term I always kind of come back to is like dissolves like. So polar substances are much more easily to be dissolved in other polar substances. Nonpolar substances dissolve in other nonpolar substances. A very common example of a hydrophobic nonpolar substance is oil. Everyone's heard the adage, water and oil do not mix, right? We know that if you try to put oil into water, it will not mix. And that is because oil is nonpolar, non-charged, and water is not. So whenever you're thinking about whether something can be dissolved in another thing, think, are these two substances similar? Does like dissolve like? So hydrophilic substances are substances that water can dissolve. Hydrophobic are substances water cannot draw into solution. And a big reason is because it's nonpolar and not charged. I kind of want to end this discussion on solutions by talking about how we can actually characterize these solutions. And one of the biggest characterizations of these solutions is it's by concentration. This is a word that, again, we are going to hear a lot of. So this is going to be a concept that we really practice with in class. So concentration can be calculated as the amount of solute over the amount of solution. Okay. So in our Kool-Aid example, right? Maybe we had 1 pack of Kool-Aid and 1 liter of water, okay? And this is going to give us a specific number. That's the concentration. The concentration, how much Kool-Aid is in this water. Now, if we increase the amount of solutes, that means we increase the concentration. So things that have a higher concentration, okay, are going to have a higher amount of the solute. There's going to be more. So let's say, for example, I put 2 packs of Kool-Aid into 1 liter of water. That is a more concentrated form of my Kool-Aid drink. We call that higher concentration. We can also decrease. So instead of doing 1 pack, maybe I just do half a pack of Kool-Aid. I just only put half a pack of Kool-Aid in. I'm going to lower my solute. I lower my concentration. There's less Kool-Aid in the water than previously. Now this is going to be something that we come back to and talk about a lot, because this is going to be really foundational to some important concepts in our next unit. So I really want you to understand that concentration is a measure of how much solute we have in our solution. And there's lots of different ways that we can measure this. So we can call it by mass per volume, so grams per liter or milligrams per liter. There's also a term called molarity. So this is actually looking at how many moles of something, which is a chemistry terminology. And as we talk about that later in the semester, you'll learn more there. But just understand that we can change the concentration of things by changing solutes. All right, in your next lecture, we'll be talking about something called pH. Thank you, guys.